Hey, physics students, Mr. Clausen here. Just wanted to go over what is acceleration. So yeah, let's take some notes and talk about things, and I'll do the best that I can to explain what's going on with it. So far in our class, we've been looking at a position versus time graph, and the only objects that we've been taking a look at are objects that travel with a constant speed. And what that ended up with is we got these nice linear graphs, or these straight graphs, letting us know that the object was traveling at a constant speed. And how do we know it was traveling at a constant speed? Is because it is a straight line. The slope at this point is the same as at that point and that point. And so since the slope never changes, the speed never changes, and the object's traveling at a constant speed. But you and I both know that that's not the only type of motion that's out there. There are objects that can change their speeds. And when you do that, you end up doing something called acceleration. So what I tried to do is I got a little video clip here of the picture. Is that just there to remind me to switch over at this point? What this is, and let's see if we can go back. Here we go. Is what I have set up is over here, I've got a little motion detector. So all it does is it just measures the distance between the cart and the motion detector. So this is my 0 point right here. And as you'll see here, the cart is going to go down the ramp. Gravity's accelerating it, causing it to go a little bit faster. And as it's going, I have a graph there plotting the points. So the cart started close to the detector, and then as it moves, it starts to get further away and further away and further away, and the position gets bigger. And what we see here, so I'll go back to the beginning, okay? What we see here is when the cart is allowed to speed up, we no longer get that nice straight graph that we had before. Now it does bounce back and forth because it stopped taking data as soon as it got down and hit the little red cart. I'm about to walk into frame there. So let's just back up. But let's take a look at what this means. So what's going on is as the cart goes down the hill, boom, and then we stop taking data right there. What's happening? Well, remember we talked about on the position versus time graph that the slope of a position versus time graph tells you the object's speed. If we look down here in the beginning, it's a very flat slope. And so that tells us that the object is not moving very quickly at all. But as it worked its way down the ramp, gravity caused to speed it up a little bit more, and it started moving a little bit faster and a little bit faster. And so if you take a look right here, we got a much steeper slope. And if you get a steeper slope, that lets you know that the object is moving faster. And so this graph here is actually showing us the graph of what am I looking for here? Of an object that's speeding up, okay? An object that's changing its speed and getting faster, and therefore speeding up. So what would that look like for us? Here's the graph that I put down there. So I drew it in. You can see here it's the same shape. It's nice and, whoops, there we go. It's nice and slow in the beginning, and then it gets faster as it goes down. Now, this lets us know the object is changing speed, and it's going to lead us to this definition of the word that we call acceleration, which is how quickly an object changes velocity. Now, you might be wondering why I said changing speed here and then switched it over to changing velocity over here. And that's because on this graph that we have right there, the position versus time graph, that's not just the speed. The slope isn't necessarily the speed on a position versus time graph. It actually tells us the velocity because in both these cases, the slope is positive. And so what that lets us know is that the object is moving away. And since it gave us the direction, this graph isn't necessarily changing its speed. It's actually changing its velocity. And that might seem like a minor distinction at this point, but it does come into it because when you accelerate, it's just anytime an object changes either the speed, which would change the velocity, or it would change its direction. Okay, and I guess since I'm leading into this, let's just go on to this one right here. There are three ways that an object can accelerate. You can go faster. So that's what I have there, a little like baseball player or softball player running, right? And so since their speed is increasing, they've changed their velocity, and by definition, that means they are accelerating, okay? The next one is we have that same baseball player here, maybe sliding into home plate. And at that point, they are slowing down. And you'll notice that if you get a slower speed, that changes your velocity. And so therefore, you'd be accelerating. The last one I have is a little bumblebee flying around. And since the bumblebee is changing their direction as they fly around, this is changing velocity. And that's an acceleration as well. A way you can think about this, though, is like anytime you are as a human and you're traveling, you notice accelerations. So if you're in a car, think about last time you were riding in a car and the car goes faster and you go back, you're speeding up, you feel that, you feel an acceleration. If you're in a car and the car slows down, like you might lean forward and you can feel that acceleration. And then, when somebody takes a, turn, you'll feel it where you go sideways like that. You're changing direction, you feel it. Other times are like, what about when you hit a bump? So say you got the cruise control on and you hit a bump, you're like, well, I felt that. Well, the car was traveling this way. When it hits the bump, it starts to travel up a little bit and then you go back down. And so you're sensing all of those changes in your motions, which means when you notice a change, that is an acceleration. And if you think about it, those are the three options that we have for it. All right, the other thing I wanted to bring up before we get too far along is what would the velocity versus time graph look like in this case? So if we think about it, the cart started out slow. So here it was up here. It was really slow up here in the beginning. And if I zoom in on the graph that I have a partial visual of, we know that the slope was really slow there, so it wasn't moving very fast. As it goes down, it starts to get a little bit steeper. And then down here, the cart is going pretty faster. And I'm just going to add a couple speed lines to it to let me know that the cart was actually going down the ramp. Now, what would that look like for the velocity graph? Let's draw it out here. Let's look at this part right here. If you're slow, this is a slow, but it's still a positive slope because it's still pointing like in this direction. And so it's going to be a small velocity. It might only be like that big at that point in time. But a little bit later, here we go, we're getting a steeper slope that's positive. And so what's going to happen is the velocity would increase and be a little bit bigger yet. And then finally, the last one is we got a really big positive slope, or otherwise this would be a positive velocity. And you get a really, a bigger velocity. So if you take a look, this one, we started out with a small velocity, then a medium velocity, and then finally we got a big velocity. If you put all those together, what you end up getting is a straight line if Mr. Clausen could have actually drawn his points where they should be, okay? And if you look at this, what this is showing us is that the object is changing its position, changing its velocity with respect to time. So every time a little bit of, say 1 second goes by, it's increased its velocity by that much, right? And then there's another one like this, and then another one like this. And so what we say here is the object is experiencing a constant acceleration because the slope never changes. If we go back to the video, the second part of this video clip, I switched over and I'm going to show you the actual velocity graph imposed on top of that. So let me hit play here. And the sensor is no longer taking data. It only does it for 5 seconds. That's why it's bouncing back and forth. All right, so if we take a look there and we zoom in, you can see I have both a velocity graph and the position graph just shown up at the same time. And we can see it's that same shape that I was talking about. Now, don't focus on this part. This is when the carts smashed into each other and things were changing. And so we're just looking at it, like if I were to slide my window up, I'm saying, look at this region right here, which is up until when that cart first went. The point I'm trying to show is the velocity graph is this nice smooth line showing that for every, I guess it's every half second here, for every half second we go over, the graph raises or increases its velocity the same amount. If I go over another half second, the velocity increases the same amount as it did the time before. And so since we have the same change in velocity every time, this cart felt the same acceleration every time. And so it felt what we'd call a constant acceleration. I'm hoping that's clearing things up just a little bit there for why the graph looks the way it does. Okay, so that's acceleration. To avoid this video getting too long, what I'm going to do is stop it, and then I'm going to pick up, and you can pick up on part 2. So we'll see you in a bit.